So here we are, finally, at one of the topics that I've been asked to cover for so long now. And the reason being is that a lot of students who have dug into programming a little bit ahead of time have realized the benefits of what this topic does. Now, we've even touched on it a little bit in some of our past assignments where I've given you some code, but let's really dig deep today because this is something that's going to change the way that we program. It's going to lead us into the true reason that programming and computers were created in the first place. So what are our objectives today? Today we're going to learn what a loop is, why we use loops, what are the components of a loop, what are the types of loops, and how to create a counted loop. What is a loop? Well, the verb loop simply means to repeat something. What? Yeah, that's it. Just to repeat something. That's it. So for example, most people, they have the same day every single day. Every day you wake up, you go to the bathroom, you eat your breakfast, you shower, you go to school, you come home, you eat your dinner, you do your homework, you watch TV, and then you go to bed. And you know what? The next day you wake up and you do it again. And then again on the next day. And then again on the next day. And it doesn't change. Every day it's the same thing in the exact same order. How often do you do this? Well, you do this about 5 times a week. This daily repetition is a loop that you repeat exactly 5 times a week. That's all a loop is. Repetition, repetition, repetition. So the purpose of computer programs as a whole is to simply automate and speed up what we as human beings do. That's why we created them. We can work and we can do the work, but the thing is, it can sometimes be tedious. We don't necessarily want to do the work and we're going to be slower at it and we're definitely going to be more prone to error. Once a program is created and it's been tested and we know it functions as is, it's never going to break. It's never going to make a mistake. That is dependable. But that's not really the problem. The reason why we did this is really because we don't want to spend the time and the effort. The thing is, we don't want to waste our time to do these things. They're tedious and they're boring. Let's see what Mark Zuckerberg has to say. He's the creator of Facebook. Now hopefully this audio comes through. I have it recording system audio, but I have a feeling it'll be a little quiet. So if it is, feel free to open up this PowerPoint and watch it separately. We'll see.
One thing that computers are really good at is repeating commands. As a person, you'd get really bored if you had to do the same thing lots of times in a row. But a computer can do the same thing millions or even billions of times and not get bored and be able to carry that out really well. So for example, if I wanted to wish everyone on Facebook a happy birthday by sending them an email, it might take me more than a century to actually write out all of those emails to everyone. But with just a few lines of code, I can have a system send an email to everyone on Facebook wishing them a happy birthday. So that's what loops are and why they're valuable and something that computers can do very well.
Oh, thank you for that advice, Mr. Mark Zuckerberg. So if he knows, everybody must know. So let's try a little experiment. In the grid on the left, you see some green walls and a robot labeled with an R, and some tools labeled with a T. The robot is capable of 5 different instructions. It can move right, left, up, down, and collect. Each movement moves exactly 1 block. Your job is to list the robot instructions that would have it collect the tools. Now obviously you want to do that in as few instructions as possible. So let's see how you can do that. So what I want you to do is I want you to pause the video here and I want you to try and write out these instructions and see, let's see what you actually get to. Okay, so hopefully you ended up with something like this. Now if the robot were to follow these basic steps, you'd have to move left, down, 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 right, 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 down, 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 left, 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 up, up, collect. So it's a total of 19 instructions to get that done. And that's fine. There's nothing wrong with that. It's a series of instructions. The robot will be able to follow that without a problem. Okay, and this is what our code is like right now. We give our programs a series of instructions when we expect it to get to the end result. That's fine. This is a sequence, a linear program. Now imagine for a second, get off of that for a second. So imagine for a second that we add a new instruction, repeat. Example, if I give you the instruction repeat 3, this will repeat the next instruction exactly 3 times. So now let's try it again, but this time with the repeat command. How are things going to differ? Well, it changes quite a bit. If we look at all the duplicate instructions we have in a row, well, that will simplify everything. So for example, the first one we have 2 of the same instructions in a row. So we can write repeat 2 and then do the left instruction. And the next one we're doing 3 downs. So we can say repeat 3. And then we're going to say do it down. And then we have 3 rights. Repeat 3 to the right. And then 4 downs. And then we have 4 lefts. And then we have 2 ups. And then we have a collect. So we just reduced our instruction set down to 13. Now this doesn't seem like a big deal, but the more repetition there is, the more clean and simplified our program is going to get. And this is also really easy to read and really easy to understand. If you're looking at the code on the left here, what we see is I might make a mistake and count wrong. I might say, oh, is there 3 arrows down or 4 arrows down? I might make that mistake. But over here, I'm not going to make that mistake because it's very clearly laid out. I know exactly how many operations I'm going to do. So what makes loops useful? Loops can be used to repeat any sequence of actions. Absolutely anything. So, oops. That could be something as simple as displaying all the names of students stored in an array. Something that we've done quite a bit already. Or giving the user 3 tries to enter a password. That's a repetition. Or something as complicated as a game loop that carries out large, complex commands within it. Things like get the user input, update all of the game objects, handle the physics, handle the collisions, redraw the screen. All of that happens within the game loop, which is much more complicated than just, say, printing out somebody's name. A little bit of a difference there. So what are the components of a loop? Every component is made up of exactly 3 parts. The first part is the comparison variable, and it always has a starting or initial value. This is the variable that's used to decide whether we're going to enter the loop or not. Maybe we shouldn't even start the loop. The next piece is the test condition. So this tests the comparison variable against some target end value to decide whether to enter the loop or not. This is anything that results in a, this whole comparison is something that results in a true or a false value. The change, so this is the third part. Change the comparison variable. We have to change the comparison variable. And that needs to be a change that works towards the end value, so eventually that loop will end. So there are 2 types of loops that we're going to look at in this course. The first one is called a counted loop. So these loops iterate a specific number of times. Now, iterate's a new word that you haven't heard before. Iterate means to go through one complete cycle of a loop. Now you might hear it spoken in English as the loop iterates 5 times. Or how many iterations is the loop? So an iteration is simply a single cycle of a loop, all the commands. So in these loops, the comparison variable is an integer that counts the iterations of the loop. So in a counted loop, we have to count how many iterations there are. We have to know. The change always moves the counter variable towards the end target value. The loop ends when the counter variable reaches that end target value. So this structure of the counter loop stays the same all the time. Conditional loops are a little bit different. They're actually simpler. These loops will iterate forever, or until the test condition is no longer true. The comparison variable can be anything here. It can be an integer, it could be a string, it could be a bool value, it could be anything we want. As long as when we do our comparison, we end up with a true-false result. So let's break this down. Counted loops. In our language, in C# and Java, whatever language we're working with at the moment, typically speaking, these counted variables or counted loops are called for loops. Most programming languages use these types. So for example, let's say we want to output all the numbers from 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, that's a pretty straightforward thing to do. You could do that on your own. Console.writeLine 1, console.writeLine 2, console.writeLine 3. Same thing over and over and over again. It would take you 10 lines of code. That's not too bad. But let's break this down for a second, and let's think about what we really want to do. What is the comparison or the counter variable starting value in this situation? Now, we want to output all the numbers from 1 to 10. Well, what's the starting value? Well, that's the 1. So if I have to define a variable to state that, I'm going to say int count is going to start with the value 1. Okay. Now I want to look at the ending target. What is my ending value? We want to keep looping until the count reaches this number. Well, in that case, it's the 10. It's written right there for us. So in this case, we want to keep looping as long as count is less than or equal to 10. Okay. And finally, how much are we going to change the counter variable by after each iteration? Now this says output all the numbers from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, and 10. So how much is the counter variable changing by each step? Well, it's changing by exactly 1. Now we know 3 ways to add 1 to a variable. We could say count equals count plus 1. That's the long form. One of the shortcuts we learned was plus equals, count plus equals 1. And then the even shortest short form is count plus plus. Any one of these 3 are perfectly viable and fine. So let's look at what the syntax of our loop actually looks like. Now you're looking at this right here. You see everything that we just did on the previous slide all in one command. So this is the for statement. So you see at the very beginning we see that int count equals 1. So that is setting up our comparison variable. And then the next piece after the semicolon is our test condition. And then finally our last piece there is the change. Now what's happening inside? Well, as long as the loop enters, so as long as count is less than or equal to 10, it's going to display the current value of count on the screen right now. So a few quick points that we need to look at. Number 1, there's no semicolon at the end of the for loop statement. We don't see any semicolon here because it's not a command, it is a structure, it is a statement. Great. You notice that the count is actually defined as part of the for loop statement. You know what that means? That means it's local to the loop, which means when the loop is done, when the loop is finished executing, this count variable gets deleted. That may or may not be a problem. Usually it's not a problem. Usually that's completely exactly what we're looking for. But there may be some situations where you may need that value of that variable after. So in that case, if you want to do that, if you want to have access to that variable after the loop, then you have to define the variable outside of the for statement. So in the example below, you can see that the int count is defined before the for loop, but we still assign it its starting value in the statement. Count equals 1. So we just don't have to define the value there. So this gives us access to the variable afterwards. So a couple shortcuts, or one major shortcut anyway. Because for loops are one of the most common structures in all of programming, we always try and find ways to simplify them. One simplification is simply to change the name of the counter variable. Count is a very long name, relatively speaking. We want to shorten it. And because it's used so much, there's a common variable name that you'll see in every programming language. So one simplification is to change the counter variable's name to a simple single letter, usually I. So the code changes to for int I equals 1. And keep looping as long as I is less than or equal to 10, I plus plus. And then we have our simple output command inside. And you notice the difference is inside, instead of outputting the value of count, I'm outputting the value of I, because that's the new variable name. Okay. So let's look at the whole order of operation. So what is the order that this code actually executes in? Because there's a lot of statements going on here. So every loop follows the exact same sequence of events. Oh, where's my thing? It's not clicking on here. There we go. The first thing that happens is we have to set up the comparison variable. Int I equals 10. You notice this loop is doing something different than the last one. This time our counter variable is starting at a value of 10. So once the comparison variable has been set up and it's been given an initial value, the next thing we need to do is we need to test it. So this flows into the test condition. And as long as I is greater than 0 in this case, which it starts out as 10, so it is, then it's going to go inside and execute the code within. So if the test condition is true, I is greater than 0, if the test condition is true, it's going to execute all of the code inside. Now when that code is done, then it goes to the change step. So it flows up back into that for statement and it modifies the counter variable working towards the end target value. In this case, this is a decreasing loop, so it's from 10 down to what? Well, as long as I is greater than 0. So what's the last value that's going to enter into this loop? Well, it's 1. So as long as I is greater than 0, we're good. But we have to move towards that target value of 0. So we do minus minus, which is the same thing as saying I is equal to I minus 1. So then what? Where does it go? So I've just changed the value. Well, now it's got to go back up. And it's going to test the variable again. It's going to test the comparison variable. If you look over the diagram on the right here, we've just created our loop. 4 goes back up to 2, 3, 4, back up to 2, 3, 4, back up to 2, 3, 4. And this process will continue until I is no longer greater than 0. At which point it will fail the test condition. The test condition will be false. And then it will continue on with the rest of the program. So when it comes back up to this I minus minus, it's going to go to 2, test it, and it may or may not pass. If it fails, it's going to jump out and jump all the way down to number 5. Continue on with the rest of the program. Every loop follows this exact same structure in all the types of loops that we're going to work with. So let's test your knowledge. Not test you knowledge, that should be test your knowledge. I suppose I'll fix that right now. There we go. Test your knowledge. What will be output on the screen? So here we have a simple loop that says for int I is equal to 10. I is greater than 0. Keep looping as long as I is greater than 0. I minus minus. So what's going to be displayed on the screen right now? Pause the video for a second and see if you can figure it out. All right. So if you figured that it would say iteration 10, then iteration 9, 8, 7, 6, the key is when does it stop? Well, it's going to stop. The last one we're going to see is iteration 1, because as soon as it subtracts one more and puts it down to 0, it fails this test, the I greater than 0 test, and it will continue on with the rest of the program. Okay, that was a nice one. Let's look at something a little bit more complicated. In this one, it's the same condition. It's the same comparison variable setup. It's the same test condition, but our change step is different. Now, instead of subtracting 1, we're subtracting 2. So what is that? What's the difference here? Well, the first value is 10. It's going to come in, it says iteration colon 10. Then it's going to come up to the change step, subtract 2, so now it's at 8. It's going to say, is 8 greater than 0? Yes, it is. So it's going to come in and say iteration 8. And this is going to keep going. And what you're going to end up with is 10, 8, 6, 4, 2. When it's at 2 and it comes in here, it comes back up to the change step. 2 subtract 2 is going to put it to 0. And then it's going to fail the test condition because 0 is not greater than 0. So that's where it's done. It's not going to enter the loop anymore. All right, so here comes the real challenging one. For int I is equal to 3. Keep looping as long as I is less than or equal to 12. I plus equals 3. So our comparison variable starts at 3. Our test condition says keep looping as long as I is less than or equal to 12. And our change step says add 3 each time. So we start at 3. It's going to display 3. Then it's going to add 3. We're at 6. 6 is still less than or equal to 12. It's going to come in. It's going to display 6. And then 9. And then it's going to add 3 more. It's going to be at 12. 12 is still less than or equal to 12. So it's going to display 12. Then it comes up to the change step. And now we're at 15. 15 is not less than or equal to 12. So that's where it'll end. So we end up with 3, 6, 9, and 12. And that is everything that we have in terms of looping. But how do we document these things? Now, I told you a little while ago that whenever we document any control structure, it's always documented in the exact same manner. What does that mean? It means that one comment above the whole structure is needed to discuss the purpose of that structure. What's that look like? In this case, loop through and display all the even numbers from 10 to 1. So that tells me that it's looping from 10 to 1, and it tells me exactly what's going on the inside of the loop. It's going to be displaying all the even numbers. How do I know they're even? Well, because I'm starting at 10 and I'm going down by 2. I'm counting down by 2 each step. 10, 8, 6, 4, 2. Great. So, but that's not the only thing. We still need to do proper documentation inside. So inside the for loop, you should be breaking your code up into blocks as normal and document them as normal. Display the current value of I. Simple, straightforward, and to the point. So today you learned all about counted loops and loops in general. Tomorrow we're going to be moving on. We're going to be applying these in new and interesting ways. Let's see how that goes.